Hello React Native developers, I hope you are well. William here recording from beautiful Zurich, Switzerland. The dbrand website is featuring a really nice animation for its color selection. And as always, you've been many asking me, can it be done in React Native? But I thought that this would be the perfect opportunity to look at mask animations, creative use of mask animations in our React Native apps can dramatically improve their level of delightfulness, and we're going to do this in 4 steps. First, to calculate the parameters of our animation, we need to have fun with the Pythagorean theorem, and so we're going to look at how to calculate the transformation of our mask. And then I want to give you briefly a sense of how the masked view component work in React Native. And finally, we're going to do the implementation with Reanimated 2, and we're also going to build the animation with the vanilla animated API from React Native. Let's have a look. All right, so let's calculate the parameters of our animations. So this circle here is going to be our mask element. This is the view, the container view, the square. And we know that so small r is half of the width of the square. And we're going to animate the scale, right? The scale of this circle. So we start at 0. This is the circle at 1. And we know that we need to go above 1 to cover completely the view. So we want to calculate the radius of this rectangle so that the view is completely covered. And so what we want to calculate here is big R. And big R we can easily calculate using the Pythagorean theorem, because here you see we have a rectangle, triangle. And so we know that big R is the square root of R square plus R square, because this length is also R, which is also half of the width. So let's calculate the maximum scale. The maximum scale is big R divided by small r, which is a radius when the scale is at 1. And so we know that big R is the square root of R square plus R square. And so this would be 2 times R square. And so this one we can move outside because that would give us R, right? Square root of R square is R. So that would give us R times square root of 2. And so scale is this divided by R. So the R simplifies themselves. And so we know the maximum scale is square root of 2. If we want, so here it's a constant value. What we can do is to change the center position of the circle. So the dbrand animation doesn't do it, but that's something you might want to do. So maybe you want the center of the circle to start here. And so you need to calculate the bigger circle. So for instance, that would be this one. And in order to do that, you simply add to the, here we have the small r. We would simply add the distance of the radius of we would add we would do the distance of the center of wherever we want our circle to start to the center here at 0, 0. And that will give us, so that would, this time it's not going to be square root of 2, right? Here we need to scale way more if we move the circle around, but that will give us the scale we need to go to in order to always cover the view. And quickly, just to give you a sense of how the masked element in React Native works. So here we have our Canva. So we are going to have 2 views overlaid on top of each other, the phone at the background and the phone at the foreground. And we're going to have our mask element, which is a circle. And the circle is, so you see here it's any pixel which is non-transparent. We can make it black. Oops. And so, okay. And then what we can do is So if I select these two elements and I can say use as mask. So you see we have a mask here. Up. I can move the mask group. So the two elements are overlaid on top of each other. And we're going to animate to the scale we need to animate to. So this is how mask element works in React Native. Before we jump into it, if you're interested to learn the fundamentals of gestures and animations in React Native, I hope that you will check out my online course at startreactnative.dev. My goal with this course is to provide you with all the tools and knowledge necessary in order to build incredible user interactions in React Native that will run at 60 FPS even on low-end devices. And I am currently building the Reanimated 2 course. There are already some lessons available and there are 5 new lessons coming out next week. So if you're interested to learn the fundamentals of gestures and animations, I hope that you will check it out at startreactnative.dev. All right, so let's jump into the code. So here I implemented the layout from the dbrand website and I also downloaded the images from the website. And so we have a state, which is a phone, which is selected. And if I press on the button, I set the state. If the phone is different from the one that is being selected, I just simply show the image. So we have the phone component, which simply shows the image of the phone. Pretty straightforward. So the first thing we need to do before jumping into the animation is that we know that the new phone overlays on top of the old phone. So the old selection, the new selections overlay on top of the old selection. So we need to change our phone state. It's not the state is not just one phone, it's two phones, the previous one and the new one. And so maybe I can call it phones, set phones. And so it's an array of phones. That looks good, but of course here I have a conflicting variable name. Let me call it set stack. It's a stack of phones. So set stack, and phone is the last one in the stack, the one which we are gonna animate. So phone is stack length -1. Perfect. And so here, if we select a phone, we set a new stack. So the element in the background is the currently selected phone, and the element in the foreground is the new phone. And so this now becomes, so we have two elements overlaying on top of each other. So we have, so we can do phone, stack map. So we get a phone. And so for each phone, we show the phone element, we pass the component and a key, we can use the phone ID. So here nothing would be changed, but we display two phones at the times. And now we can get into the animation. So here in the phone element, we're gonna wrap this one into a mask view, and we're gonna animate the mask element. So we are gonna build a mask element, which is gonna be our circle. So it's gonna be an animated view. We need to import mask view from, that would be this one. And we want to overlay the container. So we're going to use style sheet absolute fill. And here, so we would have, width equals R. That would be size actually. Height equals size, and border radius is, here we have it, it's R. So maybe I can just do it like this instead. R times 2, R times 2. And so we need a color to see it. And that would be background color black, for instance. But I guess here it can be, it's any non-transparent pixels. So here you see we have our mask. And now we're gonna need to animate. So this is at scale 1. So we need the scale to go from 0 to square root of 2. And so to trigger the animation, what I would like to do is to have a state in my component to see if the image is loaded. So ready, set ready, default value is false. The other way you can do it is using use effect. So for when with no dependencies, so when the component mounts to trigger the animation. Here, just for safety, I like to wait for make sure that the image is loaded. So use state ready default value is false. If the image is loaded on load end, we set ready to true. And so we start an animation if ready is true. And here, so in Reanimated 2, we have with timing and with spring, which attach a spring animation or a timing animation to a change of value. And in the upcoming version of Redash that will work with Reanimated 2, we have use spring and use timing, which attach a timing and a spring animation to a change of state in React. So here we're gonna have progress is use timing of ready. And I want the duration to be quite slow. Let's put 1 second. And okay. And now we can calculate the style for the view, for the mask element. So we're gonna use animated style. So style equals use animated style to be so we would have transform scale and the scale. So we go from, so on, we look at progress.value, and when progress.value is 0, the scale is 0, and when progress.value is 1, the scale is square root of 2. Let's have a look. So that looks good. But of course, in the dbrand animation, that doesn't start from the center. The center of the animation moves. So we're gonna add a translate X and translate Y, sorry. So here I think we want to calculate the maximum radius, which is, so I would do r times math square root of 2 minus the current radius, which is r times current scale.value. Let's have a look. Oh, okay. So let me put scale here. Scale here, it's not scale.value. No. I mean, pretty close, but obviously not exactly the value. So here, I'm gonna do R minus R times scale, so minus the current scale. But since here this is the scale, the radius at scale 1, we want to cap the value here at 1. So that would be minus, because we want actually when the scale is 1, we want the center to be in the middle and to not move anymore, I think. So that would be math mean of 1. Let's have a look. Yes. So now really it looks exactly like on the dbrand animation. Perfect. Before we jump into the vanilla animated animation, I want to show you a variation of this animation, which is a bit different, but just to also give you a sense about the math we use to calculate the parameters of the animations. So here in the data, I added a translation to, so here it's going to start from the center of the screen, and here we translate, so it's going to look X, so it's going to be on the side, here it's going to be on the top, no, sorry, it's going to be on the left side, here it's going to be on the top, and so on. And so I put different value, obviously, and we can apply them to the translate. So that would be fun translate.y, and same for x. And so here, the scale, as we've seen before, is not going to be correct. So it's not going to be constant anymore because it's going to depend on the distance of the center of the circle, which is based on this translate value. So yeah, you can see it here. So this one started the center, no problem. And here, the scale is not big enough. How did we calculate this square root of 2? We did hypotenuse of RR divided by R. So far, so good. But now, the distance is not R. We need to add to R whatever is the translation here. And what we need to do is to add the absolute value because we want, I mean, it doesn't matter, right? If we have a negative value, it means we will need to look at calculate it from to another corner. And we don't want to do that. So to make it look like, because at the end the scale, right, is an absolute value. To make it look like we always looking at the same distance from the same corner, I'm just gonna add the absolute value here of x. So math absolute of x, and same for y. So let's have a look. All right. And you see it perfectly covers the screen. Isn't that cool? So we can choose to translate the center of our mask element from anywhere. And this is how we can calculate the maximum scale. So just a fun variation of this animation. So now let's do the implementation with vanilla animated. So I'm going to remove these reanimated dependencies, and we're going to use animated from React Native. And I need to save this formula here for translate y. So I'm going to just put it here. So I can remove these guys here. So we have animated view. Perfect. And so here we're going to create first a progress animation value. Here, usually I use a lazy ref. So I have a UTT function which is called useConst, which is just a lazy ref, so we don't have to do the new animation value on every render. But since I don't have it here, I'm just going to use a ref for the animation value. So I'm going to do progress is use ref of new animated.value of 0.current. And we're going to use the use effect hook on ready. And if it's ready, we're going to start the animation. So animated.timing on progress. To value goes to 1, duration 1 second. Guess here it wants some easing. and we start. Use native driver true, okay. So here progress is stable, so that's fine. And so we can calculate the scale. So transform, scale, and scale we interpolate. So scale is progress.interpolate. Input range goes from 0 to 1. Output range goes from 0 to math.square root of 2. Now let's have a look. So far so good. And now we can, so it always starts from the middle. And now we can add the translate y. Can I actually do it? Let's have a look. Can I build this in vanilla animated? So we would have translate y is animated dot sub of r, and we have an animated multiply of r times scale, but we need to clamp scale. Let's see. Why it's not working? I mean, here we could use progress directly actually, and that would give us the same. Yes. Perfect. Not perfect actually. Pretty good. But no, that's not. From 0 to 1. Because at 1 we are at square root of 2, so that's why we have this. So let me put back scale here to see what we have. Here we can I? Is there like a max? I mean, I guess I could do clamped scale. So we would have clamp scale is scale interpolate. I mean, maybe there is a better way to do it, I'm not sure. So we go from 0 to square root of 1 of 2, and we extrapolate clamp. So we something like this actually. Yeah, that makes sense. Yeah. Isn't that cool? So this can be done also nicely with vanilla animated. Guys, I hope you enjoyed this example, a great user interaction built by dbrand for the color selection, and it really shows that using the masked view in our animations can really improve the level of delightfulness of our React Native apps, and there is also some fun mathematics that we need to use in order to build these masked element animations. I am looking forward to talk to you soon, and in the meantime, happy hacking!